Hello everyone, welcome back to my Math channel Math Lab. In this video, I am going to explain question number 4 from Pearson Edexcel A level exam for Pure Math 3. This exam is taken in October 2024. Paper reference code is WMA 13/01. The number of bacteria on surface is being monitored. The number of bacteria N on the surface T hours after monitoring began is modeled by this equation. Log N base 10 equals to 0.35 T plus 2. First part, find the initial number of bacteria on the surface. To find the initial number of bacteria, time is 0. For initial number, time is 0. So use the value of t0 in this equation. We will get the result as log n base 10 equals to 0 plus 2, because when you multiply t0, 0 multiplies 0.35 will be 0. You can write as 2. So it is log n base 10 equals to 2. If you remember the formula, how to convert logarithm into exponential function like this, a base b equals to c. What we are doing, we are interchanging these two. This is the base, so b power c will be equals to a. We are interchanging these two. This becomes the power, this number becomes the power. Same method here, n, or you can write here 10 square equals to n, and n will be equals to 100. So there were 100 bacteria. So this is the answer of the first part. Show that the equation of the model can be written in this form. Let me write this equation again here to solve second part. Log n base 10 is equals to 0.35 t plus 2. This is the equation, model equation given there. Actually, we will change this logarithm into the exponential form. Like I told you earlier, this is the formula. We are interchanging these two. This number becomes the power of the base. Same method we will apply here. How to convert logarithm into exponential. This number and this value of n, they will interchange, right? It is the rule. So 10 power, this becomes the power of 10. 0.35 t plus 2 is equals to n. Now you can split the powers. If you remember the rule, a power b plus c, we can write as a power b multiply a power c. We can split this addition into this way, this form, because when same bases are multiplying, powers are added. This is the rule. Same method I will apply here. There are two numbers, we can split them. So it will be 10 power 0.35 t multiply 10 power 2. Because bases are same, you can add the powers. Answer of this one is 100 into, we can split this one again, power to power rule, like b power c power d, for example. Power to power always multiplied, b power cd. It is the rule actually. So you can split this one again, 0.35 power t. Power to power is multiplying according to the rule. So solve this one by using calculator. You need to write the answer for b. You need to write the value of b to 2 decimal places. Calculator is giving you the answer 2.2387, but you need to round this answer to 2 decimal places. So it will be 100 into 2.238. Instead of writing 238, we will write 2.24. Round it up. And power is t. So it is exactly as required. And value of a is 100. And value of b is 2.24. Got it? Hopefully you will understand. This is very easy. We need to write our answer in this form, n equals to a into b power t. So we got our result exactly like that. A is 100 and b is 2.24. So this is the answer of second part. Last part of this question, hence find the rate of the growth of bacteria on surface exactly 5 hours after monitoring began. You need to find the rate of growth, number of bacteria with respect to time. Actually, you need to find the rate with respect to time, like dn by dt. Rate is always with respect to t. Okay, so you differentiate this function in terms of with respect to t to find the rate of the growth. Rate of growth is represented by dn by dt. Number of how much bacteria are increasing with respect to time. So we'll differentiate this exponential function. Let me write this value again here to solve last part. We need to find dn by dt. Don't forget this. Okay, so n equals to 100 into 2.24 power t. We will differentiate this function with respect to t to get our answer. dn by dt. Here we have exponential function. This is our exponential function. It is written like this. Let me tell you a formula. Like exponential function is always like that. A power x is a constant number, and whenever there variable is there is a formula actually. Let me tell you how to drive that formula. But it is not necessary. If you could memorize this formula, well and good. If you don't memorize, so there is a way we can solve it by taking the log on both sides. What is the rule? We take log y equals to, according to the law of logarithm, this power becomes a multiple of log. So it will be x log a. Okay. We will differentiate this function with respect to y according to the derivative. Derivative of logarithm is always 1 over y. You have to differentiate this function again. It will be dy by dx equals to, this number is constant number, keep as is, derivative of x is 1. So you can write as log a. This y multiply there, and we get the answer of dy by dx as y log a. Got it? And we have the answer for this one as y is a to the power x log a. So this is the answer of the derivative of exponential function. You can memorize this formula as well. If you could memorize, it is very good. If you don't memorize, so you can solve it like this. It is not necessary to show all the steps here. You can write directly, by the way. So log a, we will take the log of the base, and we will keep the same function as is. We are writing the same function as is and multiply by the log of base. What is base here? According to this formula, this is our base. Okay. 100 we will keep as is, and we'll write the function as is according to that rule. We'll write the function as is 2.24 power t. Now we will multiply by the log of base. What is the base? That is 2.24. This is the base. Now in the next step, because we need to find the growth after 5 hours, best thing here, you replace t with 5 after t equals to 5 hours. Substitute here to find the number of the rate of the growth of bacteria. So it will be dn by dt equals to 100 multiply 2.24 power 5 multiply by log 2.24. Okay. Now write as is in your calculator to get the answer. By using calculator you will get the answer, but this one is not dot, it is multiply. Okay, this number is multiplying. Write as is in your calculator, we will get the answer as 4548. So better you write the whole number. So these are the number of bacteria increased after 5 hours. Hopefully you understand this question. This is all about question number 4. Still, if you have a doubt or you want to write any comment about this question, please write in the comment box. Thank you.